Okay, hello to all my subscribers, and if you're not a subscriber, what's wrong with you? Press the button. Right, I'm back with another update on the emulator. I have managed to get it to do printing via a sort of an interrupt handler, and it's probably not the best way to do it, but it works, and so it's all right. I'd love to say that it works perfectly, but actually it doesn't. But anyway, I'll show you in a minute. What I've got now is I've created an opcode called syscall. But in fact, it's not actually a separate opcode because I don't have enough opcodes for that. So what I've done is I've combined it to use the same opcode number as a pop statement. And then the pop function within the emulator will deal with when it comes in as a syscall. So the way that it differentiates a system call from everything else is that, do you remember I said I could pass up to 8 registers to the pop? Well, if the last register, the 8th register, is set to a 1, then it's an interrupt. And what it does then is it takes the value of the other 7 bits as the system call number, and then it calls it. And so the system call numbers, I haven't defined functions for all of these, but I just put some in that I thought that I would use, like, the uname was fairly straightforward, and print and exit I've implemented. Some of these others I will probably do the file IO almost certainly. But basically I had to create within the CLI calls that would handle what was happening. So the emulator just has one function, which is the system call dispatcher. So it dispatches the system call number and the 4 register values to the CLI to deal with it, basically. It does some pre-processing. So if it's a print, it goes ahead and gets the string from memory and then sends the argument. The CLI has its own thread to handle this whole thing. So all system calls has its own threads, run separately, and it runs, periodically, and then when it sees one of these, it runs. Now, this doesn't work perfectly, but, I did set a system uname, so that's number 63, so I can call that to test. I can quit the system with an exit, or I can print. You can see I've still got a lot of debugging stuff in here because it's not exactly perfect by any stretch of the imagination. But the assembler does recognize now a system call. Now here I'm still using jump to exit, but I don't have to. I can use system call 0, which is basically quit. And then I can assemble this and try and load it, and we'll see if it still works with that change. And yeah, it prints hello world and then it stops, basically. Now, so I can do prints. It does support jumps and all kinds of other stuff, but I haven't implemented everything. I have had some issues, and the main issue, which I think is probably a race condition, is if I attempt to load a different message, quit out of there and assemble it and then try it again. This doesn't actually work, or at least it didn't the last few times I tried it. Yeah, it only prints hello world. It doesn't get to the second one. Before it was printing hello world twice. It wasn't. Oh, sorry, I did that. That's why it didn't work. I didn't call the But before it was calling it twice, and it probably will do that again, I suspect. I don't know. Anyway, there's still a lot of work. Like, it doesn't print the second message, and when you look through the logs, there seems to be some problem where it isn't. It's calling this before it changes the register address here. So there are some race conditions and things, but on the whole, it does work, and I'm quite happy that pretty much everything I've implemented so far in the emulator does work. It needs debugging and it needs fixing, but generally it does work, and I'm pretty happy with it. I think I'm at the point where I've learned pretty much everything I'm going to learn. Everything else would just be tidying up, really. Implementing these other things, read, write files, close, seek. These things are not going to teach me anything other than, that I don't already know, like how to open a file in Python. So a lot of these are not really going to help me learn anything additional. So I'm inclined to basically park the emulator thing. I think I've learned all I'm going to learn from doing this, and I have learned a lot. I mean, I've learned quite a bit, both about Python and emulators and how you write an emulator, but not just emulators. I've learned a whole lot about what you have to do to write an assembler, and honestly, writing a programming language, my hat's off to Dennis Ritchie, writing C, because just this assembler is a nightmare, and it took forever. So people who write compilers and assemblers and things, hats off to them. They are really, really smart, clever people, and obviously have a lot of time on their hands. But yeah, it's been an interesting little project, and I think if you fancy doing this sort of thing, it is worth trying to look at doing it. I'm probably not going to implement all of these directives either. I mean, I probably could do includes and maybe sections, and probably should do alignments, but to be honest, I don't think I'm going to learn much else from that. If I were going to do anything with this emulator, I would probably do a different type of emulator. I would probably do a full 8 registers. I'd probably do 16-bit data, and or maybe even 32-bit data and address buses. But for this particular program, I don't think I'm going to do any more. I'm pretty happy where it is. It's a bit buggy, but I really don't want to spend any more time doing it. I've actually got to get back to writing books, and because I am an author and I do want to write and complete some more books. So, by the way, I don't get any revenue from YouTube or anybody, so please have a look at my books on xgipublishing.com, and please buy a book if you are so inclined, and that'd be great. But as far as this compiler goes, this emulator goes, I'm pretty much done with it. I'll post it up. I'll tidy up the structure and things, and make it a bit more presentable, and then I'll stick it on my GitHub page. I'll put the link in the description, and if you want to check out this or improve it or implement it or re-implement it or change it or do whatever you want with it, it'll be there for you to have a go at. So if you've watched this whole series all the way through, thank you very much for watching. I really appreciate it. If you haven't subscribed yet, please subscribe, share it around, notify yourself with the bell button. I don't know what I'm going to do next, so any suggestions are more than welcome in the comment section. And I will see you all later.